Real number. Introduction to real number. What is real number? Real number is a value that can be represented on a number line. It is denoted by symbol R. Real number includes all the number such as natural number, whole number, rational number, irrational number, integers, and all types of number. What is natural number? Natural number which starts from 1, 2, 3 and move on. What is whole number? Which starts from 0 and move on. For example, 0, 1, 2, 3, 4. Rational number which can be expressed in PQ form, and the value of Q can't be 0. The value of Q not equals to 0. Integer. It may be positive integer or it may be negative integers, and all types of numbers. Here in exercise 1.1, question number 1, using Euclid's division algorithm, find HCF of a following numbers. Question 1, 135 and 225. Question 2, 196, 38220. Question 3, 867 and 225. What is HCF? HCF means highest common factor, but we have to find with the help of Euclid's division algorithm. What is Euclid's division algorithm? That we will study now. First, we have to know dividend equals to divisor into quotient plus R. We can write D equals to divisor into Q plus R. We can write dividend as A and divisor as B and Q as small q and remainder R. Let's start with question number 1. First, 135 should be greater than, is always less than 225. First we have to divide 135 with 225. So I have to multiply 135 into 1. Then by subtracting 225 value we get 90. Now this 135 should be shifted as follows. The value of 225 can be written as divisor. Here the divisor is 135 and Q as 1. So I can write 135 into 1 plus remainder equals to 90. Now the next step, this 135 is shifted to lower side, which is again divided by 90. So 90 into 1. 90 into 1. We get a value Q equals to 1, and 135 minus 90. We get a value equals to, by subtracting 135 minus 90, we get a value 45. Now again I have to divide with this 90 here. So before that I can write 135 equals to 90 into 1 plus 45. Here 90 comes downside. So now we have to divide 45 with 90. We get Q equals to 2 and remainder equals to 0. So I can write 90 equals to 45 into 2 plus 0. So the Q HCF equals to last Q value, means the HCF of 135 and 225 is equals to 45. This we can have to divide again and again till we get a remainder equals to 0. So we have performed 3 division steps. First, 225 equals to 135 into 1 plus 90, and another 135 equals to 90 into 1 plus 45, and last 90 equals to 45 into 2 plus 0. So HCF of 135 and 225 is 45. In question 2, we have to find HCF of 196 and 38220. We have to use same formula of Euclid's division algorithm. 196 is less than 38220. First, we have to divide 196 with 3220. First, in first step, I have to multiply with 1. So, 1 into 196, we get value 196. So, by subtracting 382 minus 196, I get a value 186. Now, this 2 comes downwards. So, I get a value equals to 1862. Again, I have to divide it 1764. Means I have to multiply 196 into 9. So I get a value 1764. Now by subtracting 1862 by 1764, I get a value equals to 98. So I have to now multiply 196 with 5. So I get a value equals to 980. So the remainder equals to 0. So the HCF of 196 and 38220 is 195. In same way, you can exercise 1.1. Question number 2. Show that any positive odd integer is in form of 6q plus 1, 6q plus 3 or 6q plus 5, where q is some integer. First, a be any positive integer and b equals to 6. By Euclid's algorithm, I can write a equals to bq plus r, where the value of r is equals to 0 or greater than 0 and smaller than the b. So, possible value of r equals to 0, 1, 2, 3, 4, 5. So, when we put r equals to 0 for in Euclid's algorithm, so a equals to 6q plus 0, means in adding 6q plus 0, we get a value equals to a equals to 6q. Now, I can put an integer, for example 1, 6 into 1, we get 6, 6 into 2, we get 12, 6 into 3, we get 18, 6 into 4, 24. Similar way, we can put r equals to 1. So, a equals to 6q plus 1, we get an odd value. If we are putting r equals to 2, we are getting a equals to 6q plus 2, means we are getting even number. If I am putting a value q equals to 1, 6 into 1 plus 2, we are getting even value. If instead of r we are putting value 3, a equals to 6q plus 3. If here I am putting any integer value for q, for example 2, 6 into 2 plus 3, we are getting odd value. In similar way, r equals to 4, we are getting a equals to 6q plus 4, we are getting even value. In similar way, we can put r equals to 5. There we get a equals to 6q plus 5. We get odd value. Means any positive odd is in form of 6q plus 1, 6q plus 3, 6q plus 5. Here the next question. What is next question? Question 3. An army contingent of 616 members is to be marched behind army band of 32 members in a parade. The two groups are to march in same number of columns, which can be maximum number of column they can march. Means here we have a total 616 members and army band 32. In this question, we have to find HCF of 616 and 32. HCF of 616 and 32 as Euclid's division, a equals to bq plus r, and 8 to 32 is smaller than 616. In first step, 32 is divided by 616. First 32 is multiplied by 1. So 61 minus 32, we are getting value 29. Now Q equals to 1 and R equals to 29. Now this 32 had to be shifted lower side and 29 should be divided by 32. Here 32 is multiplied by 1. We get a 32. By subtracting 61 minus 32, we get a value 29. And this 6 comes lower side. So we have a value 296. Now 32 should be multiplied with 9. So we get a value 288. By subtracting 296 minus 288, we get value equals to 8. Now this 32 comes towards lower side. Now 32 is divided by 8. So we get Q equals to 4. And 4 into 8, we get result 32. Means remainder equals to 0. When we have remainder 0 means sums came to an end. So we get HCF of 616 and 32 equals to 8.